at ideal gas equation, ideal gas law, or ideal gas situation. Now, if you have an ideal gas situation, it applies to mostly gases. You can see this kind of situation in especially at STP. Then if you look at an ideal gas is a theoretical gas that follows the ideal gas law. Then ideal gas law here is what? PV equals to nRT. If you are talking about ideal gas situation or ideal gas condition or ideal gas laws equation, the first thing that comes to your mind is what? PV equals to nRT, where P is pressure, V is volume, N equals to moles, R equals to gas constant, then T equals to temperature in Kelvin. So that is an ideal gas equation. And before then, if you look at, I said again, P pressure is P in atm, atmospheric pressure, V in dm cube, N equals to number of moles, and we have R equals to gas constant 0.082, then T in Kelvin. So PV equals to nRT is the ideal gas situation. But normally, what is even the ideal gas law? What is it about it? In a normal gas situation, high temperature, gases, all these gas particles have high kinetic energy and they move very fast. Yes, and they have negligible intermolecular forces, and under low pressure, gases are far apart. But in an ideal gas situation, like what we are saying now, ideal gas situation is a little bit different in the sense that there are no intermolecular forces between the particles. There are no intermolecular forces between the particles, and the particle occupies negligible volume. So it means that if I'm talking about this, there is no negligible volume, and collision are perfectly elastic. So if you have no intermolecular forces between particles, collision are perfectly elastic, then particles occupy negligible volume. That is an ideal gas situation. That is a perfect situation. Perfect situation of that. So that's that. Now, how do we solve equation with this? The formula for ideal gas situation, the ideal gas equation is what? PV equals to nRT. Now let's look at this. Let's look at the first question here. They said a certain volume of a gas occupies 5.0 dm cube at 2 atm when the temperature is 10 degrees Celsius. Now calculate the number of molecules where R equals to 0.082 atm dm cube. Now the formula for this thing is what? N equals to PV or PV equals to nRT. Now if you make N the subject of formula, you have PV over RT. Now in the question, this question is just a direct question. You are not converting anything. The only conversion you have here is 10 degrees Celsius. And if you look at the 10 degrees Celsius, that's the only conversion. And this 10 degrees Celsius now, you just convert it from degrees Celsius to Kelvin. It will give you what? 10 plus 273. That is 283. Now P here is 5.0. You slot it into the formula straight. Then V is what? From the P is 2 atmosphere. That's 2. Then our V is what? 5.0 dm cube. So we have 5.0 times 2. That's over the gas constant. That's 0.082. And the temperature that was converted from 10 degrees Celsius to Kelvin is now 283. So N equals to PV over RT. 5.0 over 2 divided by 0.082 times this. So you have N equals what? 0.43 mole. So the answer there is what? 0.43 mole. Let me repeat again. That's N equals what? P over RT. Slotting all the parameters from the volume to the pressure to the temperature and to the gas constant. So we have that. So that is that. Then let's look at another question to have a clearer understanding of it. And mind you, it's not every time, but most times, not even that they ask you for the mole. There are some questions they ask you for the mole. Most questions they ask you for the mole. But if you want to something like jump standard jump pass question, they might not even ask you for the mole, because the mole might be given to you in the question. They can even ask you something different. So that is that. Now let's look at question 2. Like in this situation, they said 2.0 mole of an ideal gas are at temperature minus 13 degrees Celsius and the pressure of 2 atm. What volume in dm cube will the gas occupy at the temperature? 2.0 mole of an ideal gas at temperature minus and pressure of 2 atm. What volume in DMP will the gas occupy at temperature? Just like I told you, PV equals to nRT. PV equals to nRT. That's the ideal gas equation. And if you want to make V a sort of formula, you have what V equals to nRT over P. V equals to what nRT over P. That's the ideal gas equation if you make V the sort of formula. Now from here, our mole here, that's N here, is this. We have mole, which is 2.0. Then we have temperature, which is minus 13 degrees Celsius. Minus 13 degrees Celsius, when you add 273 to it, you just have to add 273 to that so that you can get, you have 260. Then the gas constant also is 0.082. Then everything divided by what? 2. And where is the 2 coming from? The 2 is coming from what? From the mole. So we have 2 for mole, and we have 2 for what? Pressure. So nRT is what? 2R, and temperature. You understand? This is number of mole, this is gas constant R, and this is what? Temperature divided by pressure, which is 2. So if you divide this thing, that's 2 times 0.02 times 260 divided by 2. You have what? 21.32 dm3. So that is that. So most of the time, the question just be within the range. If you want to know if you are going to apply this formula, then ideal gas will be mentioned, and sometimes they'll give you at STP. If it's at STP, that's the standard. That's the standard temperature. That's standard temperature of 0 degree, which is plus 273. Then the standard pressure there is what? 760. That's 1 atm. That's STP. The T there is what? 0 degree, and the P there is what? 1 atm. That's 760 mmHg. If you are talking about Boyle's law and Charles' law. So that is that. So we have PV equals to nRT. Then from there, write out your parameters. You can always get the answer. So that is that. So if you have any question, if you have any contribution, you can just paste it on the comment box. See you in our next video. Thank you.